last week we were doing probability and we had that game to play. And you all were supposed to guess who would be alive at the end of class. Now, to give you an update, Boo Boo the bear, well, he met his end last week. So we know he's not going to be living at the end of class. Also, someone met their end. I can't remember who. It was Barry the banana. He got eaten by a veggie T-Rex. And before class ended, you all will see back Finney. Finney had died at the end of last week, right? So you all want to take another guess of who do you think will be alive at the end of class? Let me know in the chat now. There's Freddy the Frog, Fiona the Fox, Alan, Clara, Zob, Eli, and Rocco still left on the roster. Right. Now, I know this looks just like last week's question, but I changed up the values. So here's what I want you all to do as a practice. I want you all, without looking back in your books, you have to promise me you're not going to look back in your books. I want you all to take a shot at these three questions. 1, 2, and 3. And send the answers on the chat, right? You don't have to write down the question. You do not have to write it down. You just need to produce answers and send it on the chat. Also, if it's question 1, make sure you write question 1 and tell me, hey, when you send an answer, no, just don't send the answer. Let me know it's question 1 you're answering, or question 2. Good luck. 5 minutes, and don't hold back on the answer. So the first thing we should probably identify is that these things are independent events. Independent means one thing doesn't affect the other. Raining, whether it rains or not, has nothing to do with an earthquake. The two are just unrelated, right? Raining doesn't make an earthquake more likely, and having an earthquake doesn't make rain more likely. The two are independent of each other. Now, it's usually a good idea in these types of questions that you find the opposite. For example, if the probability that it will rain is 0.4, then the probability it will not rain, so I'll put a little line on top. When you put a little line on top of something, it means not in probability. And it will be 0.6. How did we get 0.6? Whenever you want to find the opposite, well, for real simple questions like this question, where there's no tricks, you just take it and minus it from 1, because probability is always out of 1. So if the probability it will rain is 0.4, to find the opposite, which is not have rain, is that you just minus it from 1, just like last week. And if the probability it has an earthquake is 0.25, then the probability it will not have an earthquake, well, everyone here could take 0.25 and minus it from 1 in their heads, right? You'll get 0.75. I trust everyone at least has up to there. This is straight out of last week. So the first question says, what is the probability it will rain on Tuesday and not have an earthquake? Well, whenever they use the word and, like you're trying to figure out if two things will happen and they are independent, we use this formula here with the independent formula. Oh, look at it. This is the formula here. You just take the events and multiply them, but you have to write it properly for the examiner to get the full marks. This is how you're going to write it. The probability that it will not rain and sorry, I made a mistake, right? The probability it will rain on Tuesday, so this is the symbol for rain, and that's the symbol for and, the same thing as intersect, and not have an earthquake. Look, I write it here, E with a little line on top. To figure out that, you take the probability that it will rain and multiply it by the probability it will not have an earthquake. We have all the values on top. The probability that it will rain is 0.4. multiplied by the probability that there will not be an earthquake is 0.75. Let me just double check this on my calculator. 0.4 multiplied by 0.75 is 0.3. So I know I told some people they were wrong, but 0.3 was the correct answer, right? Right, work out the second question and work out the third question, right? Not more than 2 minutes in total. Second one, what is the probability that it will not rain? That's the symbol for not rain. And not have an earthquake. So it's the probability it will not rain multiplied by the probability it will not have an earthquake. And once again, we have the values upstairs. 0.6 multiplied by 0.75. 0.6 multiplied by 0. A lot of people have had this one correct, so that's good news. It's 0.45. We're going to work out the third one, right? I think we had enough time to work out all of these by now, right? The next one, it just has 4 things, right? They want to know the probability it will not have an earthquake 4 days in a row. So this is how you write it for the examiner. What's the probability it will not have an earthquake, then not have an earthquake, then not have an earthquake, then not have another earthquake 4 days in a row? So instead of multiplying 2 things, I made a small mistake. I put R. I'm a little unfocused here today. I don't know why. Today was a good day. Not too sure why I'm so unfocused. Oi. Right. Instead of multiplying 2 things, we're multiplying 4 things. So it's the probability it will not have an earthquake multiplied by the probability it will not have an earthquake. And you have to write it for the examiner. Like if this is the formula for it, you can't just multiply all 4 and leave all the work in it. You will not get full marks in the exam. So it's 0.75 multiplied by 0.75 by 0.75 by 0.75. This thing here. Right? So you're multiplying it by itself 4 times. You get a real crazy number, but you can round it off to 2 decimal places, right? You get 0.3164 or something like that. Some people go to 3 decimal places, so I will go to 3 just for today. But if you go to 2, you'll be all right. Okay? 0.316. If you round it off to 0.32, still take it as correct. Okay? We could concentrate on rounding off properly at a different point in time. All right, so that's just a revision question from last week, right? Like I said, you don't need to take down anything. I just hope that you worked it out on your end. Let's go. Once again, before we move on, because you're going to see a whole set of different situations. The main word here, the main 2 words is and. Like you want 2 things to happen, something and something else. The key word here is and. And in probability, the word and is represented by the intersect symbol from Venn diagrams. And once again, this formula is only for and independent events. Let's move on to something a little bit harder, right? But this is where we ended class last week, right? Before met his end, right? He's really a freshwater fish, but he ended up in the ocean during the competition and a shark got him. Poor Finney. So Finney is out of the competition. On Dr. Evilo's island. All right. So this is where you start writing now, right? You can write down the question, everything on the screen. You don't have to take down the formulas, right? We're using the formulas one by one. Let's have a look at mutually exclusive events involving or. Now, before we did something called independent events. Independent means one thing doesn't affect the other. I think I said that quite a lot of times. For some reason, and I don't know why, some people think mutually exclusive and independent is the same thing. I know you all probably think I'm crazy that I think people think the two things are the same thing. But it's the reality. For some reason, some people think they are the same thing. They cannot be the same thing. Independent and mutually exclusive is two completely different phrases. So what does mutually exclusive mean? Mutually exclusive means the two things cannot happen at the same time. For example, I'll give you an example. The probability that you are alive tomorrow is 0.6. The probability that you die tomorrow is 0.2. Those things are mutually exclusive, meaning that you cannot be dead and alive at the same time. It's either you're dead or you're alive. The two cannot occur at the same time. Okay? Another example of a mutually exclusive. Let's say that you have a jar, and the jar has a yellow ball and a blue ball. And I tell you, according to the rules of the game, you can put your hand inside here and pull out only one of them. Can you end up, if the rules of the game suggest that you can only pull out one of those balls, can you have at the end of the game, can you have a yellow and a blue in your hand at the same time? No, because you can only pull out one. So having a yellow ball and a blue ball in your hand at the same time at the end of the game would be considered mutually exclusive. Okay? Right. So, and also the word that is going to be stressed is the word or, right? This is going to be very, very important, okay? Very, very important. I want to explain this formula here. If you want to find the probability of two things, A or B, you don't have to worry about what A means and what B means. You notice it have two formulas for or. Look at it. It have one on top. Probability of A or B is the probability of A plus the probability of B. And then you have a next one underneath. It's the probability of A or B, but this one is the probability of A plus the probability of B minus the probability of A and B. You notice one formula is for mutually exclusive events, and the other one is for non-mutually exclusive events. I wish I had paid attention more in school, because I really didn't realize it was two different formulas, right? If the two things that we are talking about is mutually exclusive, like they cannot happen at the same time, you use this formula, obviously. If the two things you are talking about could potentially happen at the same time, then you use the longer formula. And remember, this represents the word or, right? So let's try the first question. Is the first question a mutually exclusive event? We're going to assume that you're only rolling the dice once. Is the first one a mutually exclusive event? Yes, it has to be. If you roll a dice, let me say you're playing snake and ladders. You roll the dice. Can you get a 6 and a 1 at the same time? No, it's only one of them could show up. So the 6 and the 1 is mutually exclusive. And look at have the word or. So What's the probability of getting a 6 or getting a 1? Well, that would be the probability of getting a 6 plus the probability of getting a 1. We're using the shorter formula here, okay? The shorter one. From last week, do you all remember what is the probability of getting a 1? Of getting a 6, sorry. When you throw a dice, the probability of getting a 6 is 1/6 because it only have 1 6 on a dice and then have 6 outcomes. Plus, what's the probability of getting a 1? It only have 1 1 on a dice and it have 6 outcomes. So the final answer is 1/3. 1/6 plus another 1/6 is 1/3. Okay? Let's check in through your answers. Some people were able to get it way before me, which is good. You think you all could write down that and try the second question for me? Try the second question for me and send the answer. Formulas are going to be on every slide, so you don't have to worry. All right, problem time. I want everyone to write down this question. Take a 2 minutes, write down part A, B, C, and D, and then we're going to work through this piece by piece. We're going to work it out together as a team, because this is one of the harder questions out there, right? They mentioned 3 teams on a game of badminton. They said it have 3 teams, A, B, and C, right? If the probability of A winning is 1/3, the probability of B winning is 1/5, and C winning is 1/9. If you add up all the probabilities, and we're supposed to get 1, because the total probability in a situation supposed to add up to 1, right? It's like you have 2 people playing a game. If the probability of you winning is 0.3, then the probability of the other person winning is 0.7, because when you add up 0.3 and 0.7, you're going to get 1, right? Usually, the probability in a question is always add up to 1. But do me a favor, right? Add up 1/3, 1/5, and 1/9 on your calculator. You're going to have to use your fractions button, right? Add it up and tell me if you get 1. Let me know. Add up 1/3, 1/5, and 1/9. Do you get 1? By the way, probability is my least favorite topic in AdMaths, because if you don't read every single word properly and have a good imagination, it's easy to get it wrong, right? All the other topics, you can read it halfway and still get it out. Not probability. Probability is like a little English test. You are realizing you're not getting 1, right? 1/3 plus, even if you do not use a fractions button, 1/3 plus 1/5 plus 1/9 does not give you 1. In fact, it's giving you less than 1. Here's the thing. Does this mean that it only have 3 teams in this competition? Well, what do you all think? Are A, B, and C the only teams in this badminton competition? And the answer by the calculation is no, right? Because maybe it have a 14D, maybe it have a 15E. We don't know how much teams it have. It's not like the examiner said the competition only has 3 teams, right? So they just decided in this question to only talk about A, B, and C and not mention the rest. You see, when the rest of it is missing, and you have to use your imagination to say, oh, good, I wonder if it have other teams in this competition, except the examiner did not mention it. And it kind of have proof. Because if A, B, and C were the only three teams in the competition, then and they could have no draws, then if you add up all the probabilities of each team winning, you would have gotten how much? 1. So whenever you have a question where piece is missing, it's always best to work out the question safely. In other words, don't make any unnecessary assumptions. So let's get started with the first one. Also, quick question. Is this a mutual? Oh, no, never mind. I said it at the top. This is mutually exclusive. You know how I know it's mutually exclusive? There can be no draws. That means two teams cannot win at the same time. Remember, that's what drawing means. Two teams win at the same time. So this is mutually exclusive. Two winners cannot occur at the same time. Let's do part A. I need all the space I can get. So I'm going to do part A over here. Calculate the probability that either A or, they use the word or, right? B win. But that's going to be easy for you guys. You all can do this one for me. Work out A. What's the probability of A or B wins? It's mutually exclusive and you use the word or. At least do that one for me. Will be just the probability of A winning plus the probability of B winning. So it's just 1/3 plus 1/5. And I'm just going to put the I squeeze in the in here, right? I use my fractions button, right? 1/3 plus 1/5. And I get it 8/15, right? Great. So that one is easy. For part B, either A or B or C win. It's this same formula, but instead of two things, it's three things. So you add in the probability of A plus the probability of B plus the probability of what? C. So the probability of A winning or B winning or C winning is just the probability of A. You just expand the formula to satisfy three events. See if you can work that one out for me. It's mutually exclusive. You just added them up. It could be 1/3 plus 1/5 plus 1/9. Right? So it's 1/3 plus 1/5 plus 1/9. And real people selling this 29/45. Right. So I'm going to show you the key. One color, green. So for C here, they ask us, what is the probability none of these teams will win? Well, if the probability of A winning is 1/3, I'm going to put the opposites underneath, right? The probability of A not winning is 2/3. I just minus it from 1, right? Whenever you want to find the opposite, like if the probability of A winning is 1/3, then the probability of A not winning is 1 minus 1/3, right? Which is 2/3, whenever you want to find the opposite. So I just put in the opposites underneath. If the probability of B winning is 1/5, then the probability of B not winning is 4/5. And if the probability of C winning is 1/3, then the probability of C not winning would be 8/9. Everyone okay with me so far? Right? Remember, we was talking about winning, and now we're talking about not winning. So what most people would do, and I'm not going to play the trick on you this time, right? Usually I make everyone work it out in class, and when they get it wrong, I just laugh at them. right? Right? But I'm not gonna do that this time. So this is what people normally do. Well, none of them wins means the probability of this is how you write it, sorry. None of these teams win is A not winning, or B not winning, or C not winning. Isn't that reasonable to assume that most students would write that? So C can be interpreted as A not winning, or B not winning, or C not winning, right? That seems to be the most logical way of putting it, right? But here's the thing, right? So you might say it's PA with a little dash on top, PB with a little dash on top, BC, right? But work this out. You'll get 2/3 plus 4/5 plus 8/9, right? Just add it up quick on your calculator. This is the wrong answer, obviously, but it's good to know the wrong thing so you don't ever do it. Anybody seen something like this on a calculator? 2 and 16 over 45? You notice your answer is more than 2, more than 1. Remember, I told you all last week, when you're working out a probability question, right? Hey guys, make sure and see it on the calculator, right? Some people has an improper fraction. There's a 2 by 45 plus 16. That's all right. 2 multiplied by 45 plus 16. Some people have it as 106 over 45, right? Make sure you're seeing it, eh? Whenever you're working out a probability question, it cannot be larger than 1. I made sure and say this last week, that probability answers are always between 0 and 1. So if I work it out this method and I see my answer is greater than 1, that means I'm doing something wrong. I'm interpreting it wrong. And I want to show you exactly why you're getting it wrong. Remember this formula that we're using, and it can only be used for mutually exclusive events. Here we examine a trick here. Winning is mutually exclusive because they say it could have no draws. So when it comes to winning, it's mutually exclusive. But when it comes to losing, is losing mutually exclusive? Tell me something in this competition. Is it possible for two teams to lose? Yes, because if A wins, and by default, since there are no draws, doesn't that mean B and C lose at the same time? If B wins, then who lose at the same time? A and C. And if C win, who lost at the same time? A and B. So if two teams could lose at the same time, then that situation is not what? Mutually exclusive, right? It's not mutually exclusive. So you cannot use that formula for losing. Apparently, not apparently, you can only use it for winning. So how are we going to do this question now? Well, we have to find a kind of workaround. And also, we don't know nothing about the other teams, D and E, and they probably have a F. So here's how I would do this question. Didn't we just calculate the probability of A, B, or C winning? Remember the opposite? If you want to find the opposite, and the opposite of A, B, or C winning is what? None of those teams win. So the opposite would be A, B, or C do not win. I would write it like this in the exam. A or B or C. And for those who just come to the Monday maths class, you all remember this? That's the complement. That means A, B, or C does not win. You're going to find the opposite of that scenario. How do you find the opposite of that scenario? Remember, the probability of A, B, or C winning is 29 over 45. So how do you find the opposite of that scenario? Isn't it 1 minus 29 over 45? Find the answer for me, right? So when you work it out the other way, you get a number not bigger than 1. So you know you have to find a different strategy now of getting it out. And the best way to do that is to find the complete opposite of a scenario we found previously. And don't worry, the examiner will build it up just like this. Part B, he will make you do part B intentionally, knowing that if you use your brains, it will help you figure out part C. He won't leave it up to you from scratch now. He'll be kind of nice. Anybody have an answer for me? How much is 1 minus 29 over 45? I am getting 16 over 45. You think you can do part D for me? Part D is the same trick, right? Because if you do part D the normal way, I don't think you'll get an answer between 0 and 1, right? Do part D and send the answer on the chat. Right, so let's see. Part D. Remember, part D and part A are opposites. You all realize that? Part A and D are opposites. Part A is saying either A or B will win. And part D is saying, but what's the probability that don't happen? So D is really A or B with the little complement sign. It's the opposite of this happening. So remember, this is the probability of A or B winning. So the opposite could be 1 minus 8 over 15, right? Which is 7 over 15. For those who got it wrong, you think you understand it now? Great. Take down the correct working, take down. Oh, and let's see who is next on the list here. It seems the next person to meet their doom is Zob the Zombie. On Dr. Evilo's island, he found a container of radioactive material, well, in a barrel. He thought it was an energy drink, and he drank it. Poor Zob, he has met his doom. All right, so Zob is gone. Anybody out of the game? Anybody else out of the game? Because poor Zob, he's gone. Some people say they know the answer to this because they did it with Miss already. All right, so let's have another one here. Let's have a look at non-mutually exclusive, where two things can happen at the same time. Now, do not mix up mutual and independent, right? Is it possible for it to rain and have a comet hit the Earth at the same time? Obviously, right? It could be raining and a comet come and hit the Earth, okay? But tell me something. Does one affect the other? Does raining affect whether the comet is going to hit Earth? Or if the comet is coming, do you think the rain is going to stop on behalf of the comet? No. So here we have a situation where the two things are independent and non-mutual. Okay? I want you all to do the first one for me. And you notice they use the word and it's independent. So even though we have the word non-mutual written here, the first question is asking, what is the probability of it raining and a comet hits Earth? This is not an or question. I believe you have to use this formula here. And it's perfect. That formula is perfect for this case because the two things are independent. One don't affect the other. One don't care about the other, right? And they use the word and. So he's the perfect candidate to get the question correct. Send the answer for question 1. And we're going to use question 1 to help us in question 2. Coming up, so using the independent events, the probability that it rains and a comet hits Earth is just the probability it rains multiplied by the probability the comet hits. So it's just 0.3 by 0.02, which I think is 0.0. Let's make sure I get the amount of zeros correct. 0.3 multiplied by 0.02 is 0.006. And that's the answer that I'm seeing, but mostly popping up on the chat there. Right? For those who got it wrong, just make sure you understand it. Right? Right? It's just 0.3 by 0.02. Right? You think you all could do part 2 for me now? Just give part 2 a try for me. I don't care if you get it wrong. But you notice it's an or question, and we just established it's a non-mutually exclusive question. So this yellow one I'm circling is the perfect candidate to get out question 2. Because this is perfect for non-mutual, and they're using the word or in the question. See if you can get it out for me, right? Oh, anybody choose Fiona? So Fiona was desperate to win the competition, and she decided to rough it through the swamps to reach the finish line. However, the mud was too much for her feet, and she eventually got stuck. It was the easiest snack the crocodiles had in months. Bye-bye, Fiona. Anybody out of the game now? I'm pretty sure a lot of people would have chosen Fiona, right? Fiona is normally a very popular pick when it comes to this game. There's Fiona Extorf. Poor Fiona. Right. You all are going to try number 3 for me now, right? Take a 2, write down the question, right? But a change of the wording a little bit. What is the probability of it not raining and a comet hits the Earth? Right? So this one here has something to do with the opposite of raining. Well, the probability that it doesn't rain, I'll put a little slash on top. If we take 0.3 and minus it from 1, we get 0.7, right? And the probability that a comet doesn't hit Earth. I'm not too sure if we'll need that value, but I'm going to get it anyway. Take 0.02 and minus it from 1, and you get 0.98. Right. So question 3 is definitely 2 independent events, whether it not raining or a comet hitting Earth. One doesn't care about the other doesn't influence the other. And they use the word and. So I'm going to run to this formula. So they want to know what's the probability it will not rain and the comet hits the Earth. So it's the probability it will not rain multiply by the comet. Not rain is 0.7 and comet hitting is 0.02. 0.7 multiplied by 0.02 is 0.014. Right? Most people had it correct. Some people had 0.012. I'm not too sure why. Probably just for a typo. And some people missed out the zero here. It's 0.014. Some people just type 0.14. I guess they probably was typing too fast on the chat and he just forgot the zero. Now let's work on something called conditional probability. That's this formula here, right? Conditional probability is where one thing directly affects the other thing, like directly. For example, right? Let's say this is you. Happy. Everything is going fine, right? So you meet one of those fortune tellers, right? And you ask the fortune teller, what are the chances that I will die tomorrow? And the gypsy says, the probability that you die, or use D for die, is 0.0000002. Is that good news or bad news? The probability that you die tomorrow is 0.00002. Good news, right? I mean, that probability is very small. That's a very, very small number, right? That's a good number. You don't want the number to be too high, right? So you walk away happy, right? Because the chances of you dying is so small. But then the fates have changed, right? Let me draw an evil snake here, right? An evil red snake here, probably a coral snake. I don't know why it's so big. Put some white stripes on it, yellow stripes, I mean. Right. So an evil snake now bites you with his little tongue here. I know he doesn't bite with the tongue, but we just pretend the tongue has teeth. All right. Do you think your chances of dying now is the same? Knowing that you have just been bitten by the world's most poisonous coral snake. Do you think that your chances of dying will change? Yes. Now, you see, the snake bite directly affects the first probability. Without the snake, the probability of dying is 0.0002. But now, right? So I'm gonna write it for you. What is the probability of you dying? And I put in a little slash. The little slash means the word given. What's the probability of dying given that you have, I use an S for being bitten by a snake? You see how I wrote it for the examiner? What is the probability that you die given that you have now been bitten by a snake? And your probability will be much, much higher now. It might be 0.9, especially if you're far from a hospital. It's almost close to 1. It's like it's almost certain that you're going to die now. This is conditional probability, where something happens, right? Where something happens to affect the probability. It's a real simple concept, all right? So what's the formula for that, right? Well, I have the formula here, but let me show you how to put a slash, right? The probability of D, given that S has happened, you always take the probability of D and S, you put that on top, and you see the letter after the slash, P goes underneath. So the probability, so I'm gonna write it back here for next one. The probability of Q, given that T happens, you don't have to worry what Q and T stands for. That's the probability of Q and T happening divided by which letter comes after the slash? T. You divide it by the probability of T. You notice it's the same format over here, right? Take down this formula and take down this question and find and work it out for me. This one is not a trick question. It's the simplest version of this question. You can try the snake if you want, but you don't have to. The snake, I think, is just for my experience, right? Oh, big trick. I ask you to find the probability of B slash A. That is this question, right? But on this, in the formulas here, I have the formula for A slash B. In the formula here, the A comes before the B. But in the actual question, the B comes before the A. But that's okay. It's just the probability of B and A happening divided. Who comes after the slash? A. Now, it's real important to know that B and A is the same thing as A and B. When it comes to and, it doesn't matter which letter comes first. So the A jump here and the B jump here, it's the same thing, right? So the probability of B and A is 2/3. The examiner gave us that. And the probability of A is 9/13. You just use your calculator to divide that. 2/3 divided by 9/13. That's your final answer. Okay. Just checking through the answers here. Right. So no tricks, no major tricks in this. All right, try this one here now. I hope you all remember how to cross multiply. That's your hint. Write down the question and try it. Once again, the hint is cross multiply. Can you tell? You see, this question has something to do with conditional probability because it has a little slash. So, right, is E. Who comes after the slash A? So the A goes on. So that's the version of the formula you're using. And remember, B intersect A is the same thing as A intersect B. It doesn't matter if they put the A first or the B first, right? Well, when it comes to and, right? Really doesn't matter. I think it's just to substitute in your values and cross multiply. Might help you substitute in some values here. B, the examiner gave you B slash A. He came out right and said B slash A is 0.75. This is what you're trying to find in the question. And PA, where that is? Oh, 0.52. So isn't 0.75 the same as 0.75 and 1? And you have to cross multiply. Anything by 1 is itself. And then 0.75 by 0.52. 0.75 by 0.52. The answer is 0.39. And real people, not everyone got it, but a lot of people did get it. Look for your mistake. Look for your mistake. For those who got it wrong and submitted a wrong answer, you think you understand your mistake? Let me know on the chat. Sorry. Try this question here, right? Write it down and work it out. So the examiner wants us to work out A slash B. A given that B is happening. Not a problem. Let's write down the formula for that. So the probability of A given that B happens is the probability of A and B divided. Who comes after the slash? The B, right? We'll write this a little bit better. Right? B. Okay? So The examiner gave us this already. The probability of B is 0.5. Look at over here. He told us that the probability of B is 0.5. But right now, do we have the probability of A and B to place on top here? No, we do not. We have A or B, but we need A and B. But look at this. The examiner told us to assume it's non-mutual. He's telling us, look at this formula. Look at this. This is the non-mutual. So I bet if we use this formula, we could use algebra to figure out this. Now, this is where algebra skills comes in, guys. Remember, this is the add maths class. I have to assume you could solve for x, right? I get x on one side, everyone else on the other side. So let me write down this formula here. A or B is equal to the probability of A plus the probability of B minus P, A, and B. All right? Let's substitute in the values. A or B is 0.7. Probability of A, look at here, is 0.6. The probability of B is 0.5 minus the probability of A and B. And we could solve for this real easy. Like, all we need to do, how this is negative, we could take this, throw it across on this side, and we're going to take this and throw it across on the other side. So if we throw across minus A and B on this side, we get positive A intersect B. We have 0.6 here, 0.5 here, and when you throw across positive 0.7, you get minus 0.7. You think you all could work this out for me now? Work this out, and that will give you for the answer for P, A intersect B. And you just substitute it here on top and divide it by 0.5, and you're finished. That's the end of the question. You're using two formulas to get out this question. One formula gives you the value you need to transfer to the other formula. Right. So when you work out 0.6 plus 0.5 minus 0.7, I get in 0.4. Just put it on top here. So take 0.4 and divide it by 0.5, and I bet you'll get 0.8. That's your final answer, 0.8. Right. All right. So see if we can work out this question. It's a mixture form 2 maths, but they bring it back in a past paper, in a form 5 question. Okay. Oh, somebody said I didn't finish the question. Yes, no. Did I miss out anything in the question, guys? They asked me to work out PAB, right? And I worked it out. Look at that. I took this answer, I transferred it on top here, I divided it to get by 0.8. Anybody? Somebody told me I didn't finish the question. I don't know if I. Oh, okay, cool. Let's move on. All right, I want you all to try this question for me. Like I was saying, this is like, they bring a Venn diagram in this, and it's like, what? A Venn diagram in a probability question? It's going to be super popular in the exam. Work out B/E. For those who come the Monday maths class, You should have no problem with this because we are doing Venn diagrams in the Monday maths class. So you should have no problems with this question. Take a 2 minutes, sorry, take more than 2 minutes. Take a 3 minutes, write down the question, try it, and send an answer. Only 3 answers came in. All right. Let's write down the formula, right? B/A. The probability of B and A divided by PA, right? Because A comes after the slash. Now, what's the probability of A and B? Well, we know from Venn diagrams that would be 0.2. A and B, or B and A, is the intersection, right? So we know the top is 0.2. How much people actually did that part? They were sure about the top part is 0.2. Because we know from Form 2 maths, the intersect region, this is the, and intersect is the same thing, eh? And intersect is the same thing, right? But it's just the underneath part, right? We don't have the value of PA. We don't have the value PA. But here's the thing. The total probability in a complete scenario is always supposed to add up to 1. It's always supposed to add up to 1. So if here's 0.4 and here's 0.2, and you can't forget the little 0.3 on the outside there, how much missing to give you 1? You have 0.3, you have 0.2, and you have 0.4. How much, again, you need to get 1, and that value will go here. Right. It's not rocket science, right? You're going to get 0.1. So that means the probability of A is 0.1. Work that out and let me know. How much you get for your final answer? How much you getting for your final answer here? Or the total probability in a Venn diagram supposed to add up to 1. How much of you are getting 2? 2 is the answer, right? But guys, I'm doing something totally wrong here on purpose. Totally wrong. And probability is always between 0 and 1 and 2 greater than 1. If we ever work out probability and our answer is greater than 1, we do something wrong. And here's what we did wrong. In the Monday maths class, regular boring Form 2 maths, whenever you say the probability of A, they are talking about the whole A circle, eh? The whole A circle, not just the piece that the cookie by part. Is not the cookie by part. In the Monday maths class, I repeated it over and over. If I say the probability of A, I'm talking about the whole A circle. The whole A circle is 0.1 plus 0.2. 0.1 plus 0.2 is 0.3. So the probability is 2/3 or 0.666666666. You cannot make that mistake in maths or add maths or any kind of maths. If I say the probability of B, I'm talking about the whole B circle, 0.4 and the 0.2. I just saying if. Right? All right, guys. I know it's getting late. For those who understand where to get the recordings and you understand the homework, you're free to leave, right? I don't want to keep you back. I know you had a busy day. For those who have no idea, like the miss last week or the sleep away, right? Just stay back for a few seconds and I'll explain the homework to you all. Okay? Right? Right? I'm gonna just get the homework here for you guys. I'm gonna get the link. Right. So I'm sending a link on the chat here, right? I'm sending it a few times. When you go to that chat, you're going to see this. Well, sorry, when you go to that link, sorry. This is last week's class, right? It has the date and everything. I will put today's class over here. But here's the mandatory homework section. It's 5 videos. It's not due for next week. Don't worry. I'm giving it till the end of the month, right? Make sure and watch these 5 videos. When I say watch it, you're not watching it just to say you watch it. Invest your time. Make your notes. Make sure you understand it. Because in AdMaths, every teacher assumes that you learn all of those things in Form 3. And you come fully prepared just to hit the ground running in AdMaths. And you realize the same thing is going to happen in school. When you're doing AdMaths in school and your teacher teaching, the AdMaths question might boil down to a simultaneous equation. Just so it starts off with a different topic and it end up being a simultaneous out of nowhere. Your teacher not going to pause and say, well, let's revise simultaneous equations. No, you're just going to see 2 answers pop up on the screen, and he's going to assume that you remember that from Form 3. And the same thing goes with the other topics, right? If you're unable to save the link on Zoom, you know what to do. Just WhatsApp me, tell me your full name, tell me exactly what you want, like be very specific about what you want, because I teach more than one subjects, right? And I will do my best to help you. I will. I like helping people. Just tell me exactly what you want, okay? So with that in mind, guys, you are free to go.